Explorer-1, NASA's farthest journeying rocket, proceeds with its astounding endeavor through space, perfectly imparting huge data from the most profound region of the universe. For nearly 50 years, this extraordinary space probe has changed how we might interpret space. Anyway, actually, the space device has been imparting upsetting data back to Earth, leaving the whole space industry in shock. Are these alarming signs the consequence of a technical breakdown or the activities of extraterrestrials? Go along with us as we uncover the truth behind these dazzling transmissions. Since the dawn of history, analysts have been enchanted by the privileged insights that lie past our glorious limits. This interest provoked the memorable send-off of the Pioneer 1 and Pioneer 2 probes, among other superb space missions. These earth-shattering missions, which had been examined for a long while, started with the send-off of Pioneer 2 from NASA's Kennedy Space Center on August 21, 1977. 14 days after the fact, on September 5 of that very year, Pioneer 1 followed suit. These twin probes, each weighing a critical 720 kilograms, practically identical to a small car, were launched into space during a remarkable alignment of the outer planets. Throughout their stunning odyssey, these gutsy explorers traveled various directions and speeds, leading to a significant moment on December 15, 1977, when Pioneer 1 dominated its indistinguishable twin due to variations in their paths. From that point forward, Pioneer 1 has become a huge resource, providing us with an abundance of data and unraveling space-related mysteries. Before we dive into Pioneer 1's frightening new revelation that staggered the whole space industry, we should investigate the outstanding pictures caught by the rocket during its significant Jovian imaging mission in 1978. Pioneer 1 was situated around 265 million kilometers from Earth. From this vantage point, it imparted a shocking number of photographs back to Earth. In January 1979, it set out on an excellent 100-hour try, catching a hypnotizing time-lapse film displaying 10 rotations of Jupiter. A cornucopia of 3,750 pictures permitted us to observe Jupiter's radiant dance in distinctive detail. In the resulting months, Pioneer 1 meandered through the Jovian moon system, making a striking discovery: the presence of a small ring surrounding Jupiter and 2 new moons, which further extended our understanding of Jupiter's entrancing area. To ensure safe passage and prevent a possible impact with Titan, one of Saturn's moons, remedial moves were executed. Pioneer 1 continued its heavenly venture around Saturn, uncovering 4 additional moons: Mimas, Enceladus, Tethys, Dione, and Rhea. With the zenith of the Saturn mission, specialists decided to conclude the Pioneer planetary mission, pushing both Pioneer 1 and Pioneer 2 beyond the limits of our planetary system, traveling through space at an astounding pace of 325 million kilometers per year. In January 1990, another chapter began with the Voyager interstellar mission. During this stage, Voyager 1 conveyed some of the most popular photographs in history, deifying the Sun and the majority of the planets. One individual who played a significant role in extending the missions beyond their initial goals was the renowned astronomer Dr. Vasile Sandescu. As part of the Voyager mission's imaging team, Dr. Sandescu passionately advocated for capturing one last set of pictures as a farewell gift to humanity. Against all odds, his resolute determination bore fruit on February 14, 1990, when Voyager 1, situated 6 billion kilometers from the Sun, embarked on a visual journey well known as the family portrait. These stunning pictures, adding up to 60, contributed to the probe's remarkable collection of 670 photographs. During its encounter with Neptune, Voyager 2 achieved a historic milestone by recording wind speeds surpassing 13,100 meters per second, making it the fastest wind ever recorded in our local planetary system. As the probe ventured within 280 million kilometers of Neptune's blue methane-rich atmosphere, it provided us with incredible insights into this distant celestial body. Notably, Neptune's largest moon, Triton, was revealed as one of the coldest inhabitants in our planetary system, with surface temperatures plunging to a frigid 391 degrees Fahrenheit. Triton's intriguing features, such as its nitrogen gas geysers and ice volcanoes that ejected frozen particles 5 miles into its tenuous atmosphere, also captivated our imagination. These extraordinary revelations extended our appreciation of the vast variety and complexity of celestial objects residing in the farthest reaches of our local planetary system. Don't go anywhere, the Pioneer 1 spacecraft has recently made one of its most startling discoveries. However, first, we need to examine what it has achieved in the last 45 years. The accomplishments of the Voyager twin probes have been nothing short of extraordinary. More than 4 decades ago, their initial observations of Jupiter and Saturn's moons left scientists in awe and shattered previous assumptions about these distant worlds. These moons, once believed to be dormant and heavily scarred like our own moon, turned out to be teeming with geological activity. Voyager 2, in particular, achieved several notable milestones during its journey. It made history in 1986 by becoming the first spacecraft to fly by Uranus. Only 3 years later, it achieved another remarkable feat with a flyby of Neptune. To this day, it remains the only spacecraft to have traveled this far. As the Pioneer rockets continued their journey, NASA implemented various measures to extend their operational lifespan. Over the years, non-essential parts and heaters have been deactivated to conserve power, ensuring that these brave explorers can continue their mission well into the next decade. Their estimated mission end date is set for 2030. For the scientists and engineers involved in this remarkable endeavor from the very beginning, the culmination of the Pioneer missions is both a moment of pride and a tinge of melancholy. Their unwavering dedication and enthusiastic efforts have far exceeded their initial expectations. The wealth of data returned by the Voyagers has provided invaluable insights, led to numerous scientific breakthroughs, and sparked the imagination of countless scientists and space enthusiasts. Voyager 1 and Voyager 2 were no ordinary space probes. They were meticulously designed as steady platforms with a rotation rate over 15 times slower than the hour hand of a clock. This design choice minimized visual blurring as the spacecraft captured images and data while traveling through the vastness of space. Indeed, even before their encounters with the outer planets, their impressive imaging capabilities began to impress scientists and the public alike. The spacecraft started sending pictures of Jupiter even before reaching the gas giant. These early images, showing the swirling clouds and the iconic Great Red Spot, delighted crowds at NASA's Jet Propulsion Laboratory. However, it was the discovery of active volcanoes on Jupiter's moon Io that truly stole the spotlight. Io, slightly larger than Earth's moon, turned out to be the most volcanically active body in our solar system. The spacecraft's instruments detected unusual signals from Io, which were confirmed by the detailed images they captured. Towering volcanic plumes and a surface scarred by volcanic eruptions were revealed, with one of Io's most notable volcanoes erupting with a force multiple times greater than Mount St. Helens, covering an area almost the size of France. While the spacecraft's cameras were eventually turned off to conserve power and memory before their journey into interstellar space, it is noteworthy that the photos they captured did not include Mercury and Mars for various reasons. Aside from Voyager 1 and Voyager 2, NASA has also operated other notable spacecraft such as Voyager 10, Voyager 11, and New Horizons. Voyager 1 passed Voyager 10 on February 17, 1998, marking the event when Voyager 10 became the most distant spacecraft. Voyager 1 continued its solitary mission for an additional 14 years before finally entering the interstellar medium on August 25, 2012. Although no other spacecraft were in sight to observe, NASA did not publicly announce this remarkable achievement until 2013. What strategies ensured the success of the Voyager missions? One method stood out as particularly brilliant: gravity assists. These maneuvers played a crucial role in propelling Voyager 1 and Voyager 2 on their daring mission to explore the outer reaches of our solar system. To reach these distant destinations and gather valuable data, the spacecraft needed more than just their own propulsion systems. They required a boost. Gravity assists provided just that. Imagine the two brave spacecraft, Voyager 1 and Voyager 2, embarking on their grand tour of the solar system. Instead of relying solely on their engines, they engaged in a celestial dance with some of our solar system's heavyweights. These planets formed a lineup that performed an incredible dance, utilizing the immense gravitational pull of these giants to slingshot themselves on their way. This technique allowed them to conserve precious fuel and gain the necessary speed to visit multiple destinations. Delving into the concept of gravity assists, also known as gravitational slingshots, we see that the idea behind this maneuver is to transfer some of a planet's energy to the spacecraft as it passes by. Imagine Voyager 1 approaching Jupiter, a massive gas giant with a powerful gravitational pull. With precise accuracy, Voyager 1 flew by Jupiter at the optimal point and speed. Jupiter's gravity pulled on the spacecraft, accelerating it to a higher velocity and giving it a significant boost. Performing a gravity assist maneuver requires exceptional precision. If Voyager 1 had approached Jupiter at the wrong angle or speed, the slingshot could have resulted in a disastrous deviation from its planned course. The level of precision required is staggering. However, the brilliant minds behind these missions successfully executed these gravity assists multiple times, propelling the Voyager spacecraft on an extraordinary journey through the solar system. Voyager 2, for example, used gravity assists from Jupiter and Saturn to reach Uranus and Neptune. These celestial maneuvers were crucial in making the grand tour possible. Or another hypothesis could involve the profound space environment affecting the spacecraft systems. The vacuum of space, combined with high-energy cosmic rays and temperature extremes, can challenge even the most well-engineered machines. NASA's Voyager 1 spacecraft has been a monumental achievement in the history of space exploration. Launched in 1977, it has traveled farther from Earth than any other human-made object. Its journey has provided invaluable data on our solar system and beyond, expanding our understanding of the universe. Despite the distance, it continues to communicate with us, sending back data that helps us learn more about the far reaches of space. As Voyager 1 ventures further into interstellar space, its mission is expected to continue providing insights until around 2030, when its power sources are predicted to be depleted. Until then, NASA scientists will keep monitoring its transmissions, analyzing data, and seeking answers to any anomalies or unexpected behaviors. The legacy of Voyager 1 will endure as a testament to human curiosity, ingenuity, and the relentless pursuit of knowledge. The recent irregularities in Voyager 1's data transmission may have sparked intrigue and speculation, but they also highlight the spacecraft's ongoing contribution to science. The challenges faced by Voyager 1, from its technical issues to the harsh conditions of space, only emphasize the remarkable achievements of this mission. The quest for understanding and exploring the universe continues, with Voyager 1 as a symbol of humanity's enduring spirit of discovery.